All right, this is back to our Captain America problem. And so we still have the same information that's important, and I'm gonna go ahead and pull that up. So claims that voucher can be found in 20% of the boxes. However, based on their experiences eating the cereal at home, a group of students believe the proportion is less than 20%. In this particular video, we're going to create a confidence interval. This group of students purchased 87 boxes to investigate the company's claim. The students found a total of 11 vouchers for Captain America shield in the 87 boxes. Suppose it's reasonable to assume that the 87 boxes represent a random sample and that there are more than 5,000 boxes. And we're supposed to create a 98% confidence interval for the proportion of boxes that have a voucher. So let P equal the true population proportion of cereal boxes with a voucher for the Captain America shield. Our formula, since we're working for a confidence interval, is P hat plus or minus Z star. And here we have P hat times 1 minus P hat over N. Please notice I'm using P hats here, but for a hypothesis test, we use P. The reason is we claim to know P when we do a hypothesis test. We don't claim to know that when we're working with a confidence interval. We're trying to find out what it actually is. Well, when we read this, we said that they had 11 boxes, or 11 of the boxes had vouchers in it. So that was 11 out of 87. So P hat is 11 over 87, which when we take 11 divided by 87, we end up getting 0.1264. Our confidence level is 98%. All right, so our conditions, one, the first one is random sample. And it's random sample of 87 in this case, and it was given. So we're good there. Then we need to check the N is less than 10%. Well, in this case, N is 87. We take 87, we multiply it by 10, we get 870, and that's less than the population of 5,000, so we're good there. The next one, we need to check to see for normality. Well, this is different than the confidence interval. The confidence interval is NP, but here it's NP hat. So in this case, we're going to take 87 times, well, what's P hat? 0.1264. That equals 11. That's greater than 10. So we're good to go on that one. Then we need to go N times 1 minus P hat, which is 87 times 1 minus 0.1264. And we're going to round up on this, but here we go. 87 times parentheses 1 minus 0.1264. And we get about 76 boxes. So equals 76. That's also greater than 10. So we're good to go there. Please note, if it's a hypothesis test, this is a P. Confidence interval is P hat. So difference there. So we need to calculate Z star. We don't have degrees of freedom here. All right. This should be confidence level. So our confidence level is at 98%. So Z star, that's going to be a second var's inverse norm. It's going to ask for our area, which in this case is 1 minus 0.98 divided by 2, and that's going to be to the left. So let's do that. Second var's inverse norm, 1 minus 0.98 divided by 2. Mean is 0, standard deviation of 1. We're to our left. And we get 2.326. So now we're ready to plug into our formula. Well, p hat is 0.1264. So 0.1264 plus or minus 2.326. That's our Z star. And now it's going to be 0.1264 times 1 minus 0.1264 over, what was our sample size? 87. So let's go ahead and run this thing. Stat, test. We're going to have to scroll all the way down to letter A, 1 proportion Z interval. 11 is our X, N is 87. Our confidence level is 0.98. And we end up getting an interval of 0.0435 to 0.2093. All right, so I notice that 20% is in my interval. All right, so that's interesting. It could be as low as 4%, could be as high as almost 21%. So what are we? Well, we are 98% confident that the true population proportion of cereal boxes with the voucher lie within the interval 0.0435 to 0.2093. So we're 98% confident the true population proportion of cereal boxes with the voucher lies within this interval. All right. And the meaning in repeated sampling, we expect this method to capture the true population proportion of boxes with the voucher. How often? 98% of the time. All right. So I appreciate you watching and I hope to see you on the next one. Hopefully that clears things up for you guys and we'll see you on the next one. Thank you.